Hello again, Algebra 2. This is the last video for Chapter 2. What craziness. So, real quick, we're going to talk about absolute value inequalities. What we do here is we first have to graph the absolute value equation. And in this little paragraph, it says that it's very similar to graphing linear inequalities, and it's similar to graphing absolute value equations. So we need to graph the absolute value equation first, which we did back in section 2.6, special functions. Then we consider the boundary line, just like we did with linear inequalities. So is it a solid line or is it a dashed line? And then we have to shade. We have to shade to figure out where the solution region is. Because all of those points are answers. So like take a look at this example here. It's shaded below. Any of these points, anywhere here, are going to be valid solutions to my inequality that they've given over here. Y is less than or equal to 3 times the absolute value of x minus 1. So as we go through this, you'll see that we're going to get a refresher on how we graph absolute value equations, and then we'll deal with the inequality piece in a moment. So again, remember back in 2.6, we used pencils because we want to be able to erase what we don't need. So I'm just going to use a very light colored pencil. You're not going to see me erase it, but I'll go over the final answer with a marker so you can see it for certain. So let's first take a look at the first one, number 1 here. I have y is greater than or equal to the absolute value of x plus 1. The plus 1 is on the outside. So I could plot points. Again, if you're going to plot points, just go with y equals the absolute value of x plus 1. Just use an equal sign as you're trying to figure out what the graph looks like before you shade it, anything like that. Or, other option, that was option 1. Option 2 is you consider the positive and the negative version of this graph. The positive version is just y equals x plus 1. The negative version is the absolute value expression being negated. Nothing else changes. I would have y equals negative x plus 1. So the stuff in absolute value bars gets negated. So in my case, that gives me a slope of negative 1. So I need to graph both of these guys. Again, I'm going to use a light pencil so we can see that. So here we go. First I graph this guy, x plus 1. I start up at my y-intercept of 1. My slope is 1, up 1 over 1, up 1 over 1. Or down to the left. Okay, so there's one of my kind of boundary lines. They're not officially the boundary lines yet. The other option, I also start up at 1, but now my slope is negative. So I'm going to go up 1 to the left 1, up 1 to the left. Just like that. Now, I can't have an x. That's not my final answer. We ran into this when we graphed absolute value inequality or absolute value equations a couple days back. I need to test a point on somewhere on this x in my original equation. So let's test. You don't want to test where they cross. You want to test something else. Let's test this point right here. This is 1, 0. So I'm just going to come up here real quick. Test 1, 0. In the original equation, y is equal to the absolute value of 1 plus 1. Well, that's just absolute value is 1 plus 1 is 2. Does 0 equal 2? No, that's false. So that little guy right there is not on my absolute value line. That means it's the upper V. So I want all of these points. All of these points are going to make the V that I want for this particular one. It is a greater than or equal to, so I can make these a solid line, both directions. And because it's a greater than situation, I'm going to shade above. Greater than, shading above the V. You could test a point in there as well if you wanted to in your inequality. Let's talk about another. How about number 7? This one's going to take a little bit of finagling, just a little bit. Notice the x's and the y's are on the same side. That's not good. So I need to get the x's on the other side. The y is already positive, so that's good for me. What I'm going to do is just subtract the whole absolute value thing, leaving me with y is greater than negative absolute value of 2 minus x minus 1. I'm going to take the positive and the negative version. So my positive version is y equals, remember we're going to pretend it's not an inequality at first, y equals the opposite of 2 minus x minus 1. Notice here, the negative symbol was already there. It's on the outside of the absolute value bars, so I have to keep it. The negative option is y equals the opposite, because again it was there already, everything inside negated, so it's going to be a negative 2, a positive x, minus 1. The minus 1 does not change because it's outside of the absolute value. The negative right there does not change, it's outside of the absolute value. I'm going to simplify both of these just a little before I continue. When I distribute in that negative 2, I get negative 2 plus x minus 1, so my final positive option equation is x minus 3. In this guy, when I distribute, I get positive 2 minus x minus 1, so my final negative option is negative x plus 1. These are my two that I'm going to graph. This guy, I'm going to start down at negative 3. My slope, oh, I was supposed to do that in pencil. My slope is positive 1, so I'm going to be going up like that, down like that. This guy, I start up at positive 1. My slope is negative 1. So I'm going to have something that looks like that. Now I need to test some points to know which of those I have. And you're going to go back into the original as if this were an equal sign. So let's test, this point looks nice. This is 4, 1. So I'm going to test 4, 1. When I test 4, 1 in my original, I should get 1 is equal to the opposite of the absolute value of 2 minus 4 minus 1. That gets me negative 2 in absolute value bars, negated, minus 1. That gets me up 2, but it's negated, minus 1. Does 1 equal negative 3? No, so that's not a point that I want. So I want the lower v. Oh, and it was supposed to be dashed. Oh no. That's why it's great that you guys work in pencil. So, but because I made this mistake, and you guys might make this mistake too at some point, what I'm going to do to show that I actually wanted it to be dashed is just draw little lines along it, like a scarecrow mouth or something like that, just to say that, oh, that was supposed to be dashed. I promise that's like the international symbol in my classroom. So there we go. Now I have to remember that it was an inequality, so I have to shade. Remember, I had, before I thought it was an equal sign, right? I have a greater than symbol, a greater than symbol. So knowing it's a greater than symbol, I am going to shade above. Everything above is fair game. There we go. Awesome. Alrighty. And yeah, let's do one more. Let's not do one on your page, but I am going to utilize, I think, this graph, maybe this graph, one of those. Let's just use this space over here to write it. So, let's say I had y minus 3 is greater than or equal to negative 2 absolute value of x plus 4 in absolute value. I wanted you guys to see this one because it has a lot of stuff going on. A lot of stuff. So, just like number 7 had a lot of stuff, this has a couple more things. So again, I want us to graph this. I'm going to first pretend it's an equation instead. And I am going to finagle this so it's y equals stuff. Meaning I'm just going to add this 3 off to the other side. So I have negative 2x plus 4. Once I have it as a y equals equation, oh, plus 3, that would be nice. Once I have it as a y equals equation, I can split it into the positive and the negative version. My positive version is y equals negative 2 x plus 4 plus 3. My negative version is y equals negative 2 times negative x minus 4 plus 3. Sorry, it's a little slanted there. So again, the x plus 4 was in the absolute value. That's the only thing that gets negated in my negative version. I'm going to simplify a little bit. I end up with negative 2x minus 8 plus 3. So that's negative 2x minus 5. Over here, I get y equals, I'll twist this so you guys can see it straight, positive 2x plus 8 plus 3. So I have 2x plus 11 and negative 2x minus 5. Those are my two. So I'm going to use, which one of these is going to fit? I'm actually going to use number 8 all the way down here to graph, and I'm going to count by 2s just to make sure I can fit everything on. So making a note just to myself, I'm counting by 2s. For this example, up there. So, there we go, we can see the equations up there. First one, if I'm counting by 2s, I need to be down at negative 5, 2, 4, negative 5. My slope is negative 2x. So because I'm going to count by 2s in both directions, I can actually just use my boxes. Technically, I'm going to go up 4 to the right, or sorry, to the left 2. So up 2 to the left 1. My red's not working. Up 2 to the left 1. Up 2 to the left 1. Notice I'm always in the middle of my boxes. Down 2 to the right 1. There we go. Other option is I'm up at 11. 2, 4, 6, 8, 10. 11's right above there. My slope is 2. I don't have any more space above here, so I'm going to go down. I have, I'm going to add another line just for that guy. I'm going to go down 2, left 1. Notice how I get my positive slope when I do that. Down 2, right, sorry, left, wow. Down 2, left, down 2, left, down 2, left. That's my x forming. So now I need to test a point in my original equation. And I would go back to the original right here even, before we added the 3 over, because we might have done that wrong. Go back to this original one. So let's test on my line. Looks like, yeah, I'll test this one. This is down as at negative 5. So I'm going to test 0, negative 5. So I should have y minus 3 is equal to negative 2, absolute value of x plus 4. That's going to get me negative 8. This is going to get me negative 2 times the absolute value of 4, which is just 4, which gives me negative 8. Glorious, meaning I like this graph right here, the lower v. Last part, it is an inequality, so we have to check, did I want it to be dashed or solid? Going back up here, I wanted it to be solid, so that's good. And I want it to be greater than. So even when we moved the 3 over, this is a greater than symbol, a greater than symbol. So, greater than this v, I'm going to shade everything above. All of these are valid points there. And take a look at this. This is partially why I wanted you to see this example. Notice my v that I didn't pick is in my shaded region. All of these points were in my shaded region. This is why it's important that we do our test in the equation. This is why it's important to do the test in the equation. We need our answers to fit the equation that is the v. That's how I know where the v is. It's only when I shade that I worry about the fact that it's an inequality. So, keeping that in mind. There we go. Okay. Excuse me. It'll take a little bit of time, as you can see, especially if you're talking through the whole thing like we were. So there we go. A couple different things about absolute value inequalities. That's the last thing in chapter 2. So we will continue talking about all of this in class later.